Good day, this is Teacher Rowan. I'll be your guide in exploring Google Apps for education, for teaching and learning. In Google for Education, teachers can connect and collaborate easily while staying on task. It gives teachers the freedom to spend more time personalizing the learning experience and less time managing it. Students can learn essential skills such as 21st century problem solving, which they can use it in their future careers. As such, the accessibility features will also help and assist every learner to do their best work. Google offers different useful applications that we can use to connect education to technology. This will help our teachers as a 21st century educators to innovate and find ways on how to make teaching and learning more exciting, engaging, effective, and flexible to the demands of the society. Let's re-explore the education experience by discovering new angles to create, collaborate, and communicate as one. Para sa bata, para sa bayan, at para sa guro. Ang pagkatuto, huwag gawing komplikado. Sulong edukalidad.
Mabuhay! Good day to all! I am your tutor Madge. Welcome to ETUlay, a free online tutorial, an initiative of the Department of Education, Information and Communications Technology Service, Educational Technology Unit, SHS-Edtech. This program is aimed at helping and assisting learners from kindergarten, senior high school, ALS, Alive, and SPED learners. Aside from answering the modules, the ETUlay is offering programs which you will surely look forward to. Together with our parents and teachers, the ETUlay will bridge the gap where difficulty and ease meet in learning new knowledge and skills. So, let us prepare our module, pen and paper. Ready your mind to see and hear worthwhile and interesting lessons. Let us now study and learn together with our volunteer online tutor. Tara na! Tara na!
Good afternoon po sa inyo lahat. Wow, it's been a long time. So, good Monday afternoon. Magandang hapon po sa ating mga viewers all over the Philippines, Luzon, Visayas, and Mindanao. I do hope you're all doing well. At maligayang araw ng mga puso po sa lahat. Naway manaig po ang pagmamahal sa kabila ng mga pagsubok po ng pinagdaraanan natin. Ito po ang ating first ETUlay live session for the Senior High School Physical Science, third quarter of the school year 2021-2022. Once again po, ito po ang inyong tutor, Tutor Lester from ETUlay National High School, SDO Ormoc City, Region 8. Meron po tayong isang volunteer tutor na makakasama sa ating live session kada Lunes po, 4 to 4:40 in the afternoon. So, I know you're all excited to have him in this session. So, welcome po sa ating session, Tutor Neil from SDO Pasig City.
Ayan, thank you po, Tutor Lester. Good afternoon sa inyong lahat. Ako po si Tutor Nel from Buting Senior High School of SDO Pasig City. Excited na akong makasama kayong lahat starting today para mapag-aralan natin ang mga concepts sa physical science. Tutor Lester?
Thank you, Tutor Nel. Ayan, may katandem na po ako. So kung dati po, ako lamang po ang inyong nakakasama every Monday afternoon, may kasabay na po tayo habang pag-aaralan natin ang mga concepts sa physical science. Right. Okay, bago ko po introduce ang ating topic for this week, batiin po muna natin ang ating mga live viewers. Alright, binabati po natin ng isang magandang hapon at Happy Valentine's Day sa ating mga live viewers. Joseph Conrad Bulaklak from Pasay City North High School. And Edward Digolio Ladit from Alibadbad National High School. Alright, magandang hapon po sa inyong lahat. So, for the first week of the third quarter of the school year 2021-2022, we will discuss the topics formation of heavy elements and concept of atomic numbers. Ang pinagbasehan po ng ating live session ay ang Physical Science ADM module ng Region 4A, Calabarzon. Alright, ang ating pong subject na tatalakayin in this live session is Physical Science, isang course subject that is offered in grade 11 or 12, depende po sa region. So this is the description of the subject.
Ayan. Physical science involves the discussion of evolution of our understanding of matter, motion, electricity, magnetism, light, and the universe from ancient times to the present. It also discusses the application of physics and chemistry concepts in contexts such as atmospheric phenomena, cosmology, astronomy, vision, medical instrumentation, space technology, drugs, sources of energy, pollution and recycling, fitness and health, and cosmetics.
All right, thank you po, Tutor Neil. So for this Monday, for this session rather, we will take up the following most essential learning competencies, which are the following.
Okay. First one is give evidence for and describe the formation of heavier elements during star formation and evolution. So we will discuss the star formation and how elements are formed in the core of the stars.
And explain how the concept of atomic number led to the synthesis of new elements in the laboratory. In this competency, we will discuss transmutation, or how to change the element into a new one. All right, let me share a quote from Carl Edward Sagan, an American astronomer, planetary scientist, cosmologist, astrophysicist, astrobiologist, author, and science communicator. The nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies were made in the interiors of collapsing stars. We are made of star stuff. Kayo, mga minamahal naming mga live viewers, together with me, Tutor Lester, and Tutor Neil, will explore how we are all made of star stuff. Since this is the first week for the third quarter, atin pong i-refresh ang basic knowledge natin on atoms. So we will be dealing with equations po, and this is fitting that we recall the concept of the atomic number and the mass of the atom. The atomic number is equal to the number of protons in the atom, and the atomic mass is determined by the sum of the protons and the neutrons in the nucleus. Right? So, bago po nabuo ang mga bituin at mga galaxies, nagsimula ang lahat sa isang Big Bang ayon sa teorya ng mga siyentipiko. Alright, so please do not get misled by the term Big Bang. Hindi po nagsimula ang universe sa isang pagsabog. So ano po ba ang nangyari sa Big Bang? So ang Big Bang po ay isang madalian at mabilisang paglapad ng singularity na pinagsimulan ng universe 13.8 billion years ago. Matapos ang 3 minuto, ay nagsimulang mabuo ang mga elementong hydrogen at helium kasama ang iilang lithium at beryllium. So ito po ang elements number 1, 2, 3, and 4 na makikita nyo po sa inyong periodic table. So from that moment when Big Bang nucleosynthesis occurred, there were lots of helium and hydrogen that were formed. So clouds of these gases. Ano po ang naging papel ng dalawang element na ito sa formation ng early universe? So what happened to the helium and hydrogen that were formed right after the Big Bang nucleosynthesis?
Ayan. Lumipas ang 200 million na taon, and because of the force of gravity, these clouds of gases and dust are compressed until fusion reactions begin. From the clouds of hydrogen and helium, stars are born. And from there starts stellar nucleosynthesis. Lahat ng mga element na makikita natin sa periodic table, except those that are artificially prepared, ay nabubuo sa core ng mga stars.
Yes, Tutor Renel. So, matagal na panahon bago nagsimulang nabuo ang mga bituin. Ang 200 million years ay maaring napakatagal na panahon in our point of view. But in the universe, 200 million years is just a blink of time, given that the universe has existed for billions of years. At ngayon po, atin pong talakayin ang iba't ibang life stages ng isang bituin. Magkaiba po ang life stages ng average size star, kagaya ng araw po natin, at ng mga naglalakihang mga bituin. Nagsisimula ang isang bituin bilang isang dust cloud o nebula. Ang laman ng dust cloud na ito ay mostly hydrogen. Sa pamamagitan ng puwersa ng gravitation ay kinumpol ang dust cloud hanggang magkaroon ito ng core. Kapag ang isang protostar ay nagkaroon na ng sapat na temperatura para simulan ang nuclear fusion, ito ay nagiging isa ng ganap na bituin. Kapag isang ganap na bituin ang isang protostar, ito ngayon ay tinatawag na nating main sequence star. Main sequence stars gives off light and heat because of the fusion of the hydrogen in its core. From our discussion, we had emphasized that hydrogen is the fuel that powers the stars. So for a main sequence star, ano po ang mangyayari kapag naubos na po ang kanyang hydrogen sa kanyang core?
Yan. Kapag naubos na ng main sequence star ang hydrogen nito sa kanyang core, lumalaki ito at nagiging isang red giant. To continue giving off light and heat, it uses helium as fuel to sustain the nuclear fusion at its core. Para naman sa di masyadong kalakihang red giant na nauubusan na ng energy source, ito ay nagiging isang white dwarf. Nangyayari ito kapag naubos na ang helium sa kanyang core and the stars could no longer perform nuclear fusion. It blows off its material into space at ang natirang core ay kumikinang lamang dahil sa napakainit itong temperatura. Nagiging black dwarf ang isang white dwarf matapos nitong lumamig. Sa ngayon ay wala pang nakikitang kahit isang black dwarf dahil ito ay isa lamang hypothesis ng mga siyentipiko.
Yes, yan po ang life stages ng mga average size stars na kagaya po ng ating araw. Iba naman po ang stages ng isang star na mas malaki pa po kaysa araw. So, when massive stars depletes their hydrogen in the core, the star shifts to helium to power itself and transition into red giant. And when that helium is used up and is heavy with elements like iron, sumasabog ang mga ito bilang isang supernova. That happens after several million years as a super red giant. And how about the core of the star that went supernova? Ano pong nangyayari sa core? So, there are two possibilities. One of the possibility is that it may become a neutron star. So a neutron star has a very strong gravitation o mayroon po itong napakalakas na gravitation. Kung ang core naman ay supermassive o mas mabigat pa kaysa neutron star, ang natitirang core ay nagiging isang black hole na may hindi kapanipaniwalang gravitation na kung saan pati ang liwanag or light ay hindi maaaring makatakas sa taglay nitong lakas. Right? So naipaliwanag na po natin ang iba't ibang life stages ng mga average size stars at ng mga very massive stars. Why do stars undergo different life stages? So para po sa ating mga live viewers, pwede nyo pong sagutan ang katanungan by commenting po here in our live stream. Alright, habang inintay po natin na may sumagot po from our live audience, we are inviting our live viewers to like and share po ang ating live session sa Physical Science po third quarter week 1. Okay. So, may iba't ibang proseso na nangyayari sa core ng mga stars. So, these processes helps explain why stars undergo the life stages presented earlier. So let us start with the proton-to-proton chain reaction. So sa proton-proton chain reaction, nagsasanib ang dalawang hydrogen nucleus o proton. Ang pagsasanib ng dalawang hydrogen nucleus ay lumilika ng deuterium. Ang deuterium at isa pang proton ay nagsasanib para makabuo ng helium-3. Kapag nagsanib ang dalawang helium-3, ito ay nakakabuo ng helium-4 kasama ang dalawang panibagong hydrogen. Okay, so that is for the average size stars. How about for the stars that are bigger than our sun? So how do these stars produce energy?
Ayan. Para naman sa mga stars na mas malaki pa sa average stars, they use what we call the CNO cycle to produce helium as shown in the process. Carbon-12 fuses with hydrogen to form nitrogen-13. Hindi stable ang nitrogen-13, so it disintegrates into carbon-13 and an electron. Carbon-13 then fuses with hydrogen to form nitrogen-14. Nitrogen-14 fuses with hydrogen to form oxygen-15. Hindi rin stable ang oxygen-15, so it undergoes a beta decay, forming nitrogen-15 with an extra electron. Nitrogen-15 will then fuse with hydrogen to form carbon-12 and a helium. And then, the process is repeated.
Alright. So kapag naubos na po ang hydrogen sa core ng isang main sequence star, ito po ay nagiging red giant at ang ginagamit nito to power itself is helium. So this is possible through the tri-alpha process. So sa tri-alpha process, nagsisimula ang proseso sa pagsasanib ng carbon-12 at helium to form oxygen-16. Ang helium-4 at oxygen-16 ay bubuo ng neon-20. Every product fuses with helium-4, gaya po ng nakikita nyo po sa slide, until iron is formed. And all these iron are deposited in the core of the stars. So far, in the process that we have presented, ang naipakita pa lang po natin are the fusion processes that produces up to iron. So how are elements heavier than iron formed in the core of the stars? Alright, so if you want to share your answer po, okay, you may comment po dito sa ating live stream. So how are elements heavier than iron are formed in the star's core?
Yan. Hindi lamang bakal o iron ang nabubuo sa mga bituin. Ang mga elementong mas mabibigat pa sa iron ay nabubuo sa core ng mga stars sa pamamagitan ng neutron capture. Maaaring ito ay slow or rapid capture. Kapag slow capture, ang prosesong ito ay napakatagal na panahon dahil pa isa-isang neutron lamang ang sumasanib sa mga iron nuclei. Ang S-process o slow capture ay bumubuo ng elementong kagaya ng cobalt na mas mabigat pa sa bakal. Ang R-process naman o ang mas mabilisang neutron capture ay nangyayari during a supernova o pagsasanib ng dalawang neutron star.
Right? Now we move on to the second note for week 1, which is the concept of the atomic number that led to the synthesis of new elements in the laboratory. Right? So shown in the slide is a sample of a nuclide. All the process shown to you are illustrated via an equation. A nuclear equation in which of course kasama po ang mga nuclides. Ngayon po, atin pong i-refresh ang ating nalalaman on nuclides. This topic has been discussed in your junior high school. All right. So the number on the lower left is the atomic number of the element. The atomic number pertains to the number of protons in the nucleus of the atom. On the upper left is the atomic weight, which is the sum of the number of protons and neutrons in the nucleus. And lastly, this is the element symbol. So this is a nuclear equation. So on the left side of the equation, you have there the reactants or the elements that are fused or smashed together. On the right side, you have the products and the byproducts that are formed. How do we balance nuclear equation? So, para mabalanse po natin ang nuclear equation, dapat balanse po ang atomic number in both the reactants and the products. In this example, we have nitrogen 14 that fuse with an alpha particle, which is the nucleus of a helium atom. So these two are smashed together, forming oxygen 17 and a proton. Right. So ano po ang atomic number ng nitrogen? Yes, that is 7. And for the alpha particle, 2. So ano po ang total ng mga atomic numbers? Right, 7 plus 2 will give us 9. Right. How about sa bandang product? Right. So the atomic number of oxygen is 8 and the atomic number of a proton is of course 1. So if you'll total the atomic numbers, so we'll get 8 plus 1 is equals to 9. So ibig sabihin, both the reactants and products atomic number are balanced. Now we look into the atomic weight in the reaction. So tingnan po muna natin dito sa bandang reactants. So nitrogen has a mass of 14 and an alpha particle has a mass of 4. So 14 plus 4, that gives us 18. Okay, dito po sa product na side. Oxygen here has a mass of 17. Then add that with the mass of a proton, which is equal to 1. So 17 plus 1 will give us 18. So 18 po ang mass ng reactants and 18 po ang mass ng products. So, the equation po is balance. Alright. So, remember, in balancing a nuclear equation, dapat isalang-alang po natin na balance po o magkapareho po ang atomic weight at atomic number ng reactants at ng products. Now, Tutor Ronel will discuss to us the discovery of nuclear transmutation and how nuclides are transmuted or changed from an element to another.
Yan. Nakagawa ng panibagong isotope ng oxygen si Rutherford kasama ang isang proton sa pamamagitan ng pag-smash ng nitrogen-14 sa isang alpha particle. Ang nuclear equation na nababasa ninyo ang pagsasalarawan ng pagkadiskubre ng neutron, where a beryllium nucleus is bombarded with alpha particles producing carbon-12 and a neutron. Ang beryllium ay may atomic number na 4 at atomic weight na 9, na siyang idinagdag natin sa atomic weight ng helium na 4 at atomic number na 2. Ang carbon-12 ay may atomic weight na 12 at atomic number na 6. Ang neutron naman ay mayroong mass na 1 at 0 ang atomic number dahil wala itong charge. Ang technetium ang kauna-unahang artificially prepared element. It is not naturally occurring on Earth. Ibig sabihin ay wala po tayong makikita na technetium sa kalikasan. Ito ay nadiskubre noong 1937. Technetium is formed together with two neutrons by the bombardment of molybdenum by deuterons, or an isotope of hydrogen. Ito namang nababasa ninyo ngayon, ang pinakaunang nuclear chain reaction na ginawa sa isang nuclear reactor sa University of Chicago noong 1942. A neutron was shot at a uranium-235 nucleus producing bromine-87, lanthanum-146, and 3 neutrons.
Thanks, Tutor Nel. So, in the 1930s, the heaviest element known that occur in nature was uranium with the atomic number 92. When elements having atomic numbers greater than 92 were synthesized, so they were known as the transuranic elements. All right. Edwin Macmillan created a heavier element named neptunium, as shown in the equation. So the more abundant isotope of uranium, uranium-238, is bombarded with neutrons, synthesizing neptunium-239 with an electron as a byproduct. Super heavy elements are artificially prepared elements with atomic numbers higher than 103. So these super heavy elements are produced by bombarding heavy nucleus with accelerated heavy projectiles such as the one as shown in this slide. In the example, we have Bismuth 209 bombarded with the high-speed projectile of chromium-54, synthesizing borium-261 with 2 neutrons as a byproduct.
Ayan, so we had shared to you the life stages of stars and the different processes that takes place in its core. We had also shared to you how to balance nuclear equation. So, for our activity po, let us try to write a nuclear reaction involved in the synthesis of the elements named as follow. Number 1, curium with the atomic number of 96 was formed by reacting plutonium-239 with alpha particles. Number 2, mendelevium, atomic number 101, was formed by reacting einsteinium-253 with alpha particles. Sa ating mga live viewers who are willing to share their answers, please do so po by leaving a comment in our live stream. So before we write our nuclear reactions, let us first acknowledge our live viewers right now. Ayan, so salamat po sa walang sawang pagtutok at pagsama sa amin dito sa ating mga live sessions. Muli po ay isang maligayang araw ng mga puso para sa ating lahat. Special mention ko lang pala muna ang ating mga viewers from Buting Senior High School of Pasig City. Salamat po sa inyo.
Alright. Maybe you are still doing po your equations. So, sa mga hindi pa po nag-share ng ating live session, please do like and share po our live session po sa Physical Science for third quarter week 1. Alright. Sa mga hindi pa po sumagot, so sabay po nating sasagutan ang mga equations. Alright. So for the first equation, ano pong element ang na-synthesize at ano po ang mga reactants. Alright. So tama. So we write down, okay, we write down curium as the product and plutonium and alpha particle as the reactants. Ayon sa equation, ano ang atomic number ng curium? Alright, so tama po, it's 96. So we write down 96 for curium's atomic number and check on the periodic table kung ano po ang atomic number ng plutonium at ng helium. Alright, so ang atomic number po ng plutonium and helium is 94 and 2 respectively. So from there, we can see that the atomic number in the reactant side and the product side are balanced. Now we balance the atomic masses. Ano po ang mass ng plutonium ayon sa equation? Okay, you may refer to your periodic table or you may look at the equation. So according to the equation, ang mass ng plutonium is 239 and the mass of helium is 4. So when we get the sum of the atomic mass of plutonium and helium, so we can discern that the mass of curium is equals to 243. Ayan. And now everything is balanced, which makes the equation correct.
For the second equation, ano ang element ang na-synthesize at ano ang mga elements na nasa reactant side? Tama. Okay? So we write down mendelevium as the product and einsteinium and the alpha particle, which is the helium nucleus, as the reactants. Ayon sa equation, ano ang atomic number ng mendelevium? Okay, so it is 101. So we write down 101 for mendelevium's atomic number and then check on the periodic table kung ano ang atomic number ng einsteinium at ng helium. So what are the atomic numbers for einsteinium and helium? Okay, that is 99 and 2. So from there, we can see that the atomic numbers in the reactant side and the product sides are balanced. Now, we balance the atomic masses. Ano ang mass ng einsteinium ayon sa equation? Okay, that is 253. And then, if we check on the periodic table kung ano ang mass ng helium, we will find that it is equivalent to 4. So, we add up 253 and 4, and that makes the mass of mendelevium as 257. And now, everything is balanced, which makes the equation correct.
All right. This third equation should serve as your practice rin po. So the equation goes like this. Meitnerium with atomic number of 109 was formed by cold fusion, which involves the combination of bismuth and iron nuclides at ordinary temperature. So once again po, para mabalance natin ang equation, write which elements should be on the reactant and on the product side. Write down the atomic number of the product, then refer to the periodic table for the atomic numbers of the reactants and write it down. The atomic numbers should be balanced. And when you had balanced the atomic numbers, balance din po ang atomic weights. Refer to the periodic table po. So look for the atomic weights of the reactants. Then add the atomic weights. So the total of the atomic weights should be equal to the atomic weight of the product. Alright. So habang inaantay po natin na may mag-share ng kanilang mga answer, once again, we are inviting you, our live viewers, to please like and share po ng ating session sa Physical Science. Batiin rin po natin ang ating mga live viewers. Alright. Happy Valentine's po to Divine Liporada Sablayan of grade 11 ABM Kaibiga High School. And happy Valentine's and magandang hapon po kay Mary Grace Bejo of 11 Gas Kaibiga High School. Happy Valentine's and magandang hapon din po kay Darwin Abalos. And magandang hapon rin sa ating masigasig na live viewer na si Joseph Conrad Bulaklak. Okay, pasensya po Mr. Bulaklak kung hindi po namin na-acknowledge agad ang inyong mga answer, at to all the live viewers whom we haven't acknowledged their answer po. Pasensya po. All right. I will also take this opportunity to greet the learners and the teaching and non-teaching staff sa aming school po sa ETUlay National High School of SDO Ormoc City. I would also like to greet our superintendent, Ms. Marilyn Xiao, and Ms. Elena Angelita Jose, our school head. All right. So meron na pong nag-share. Okay, meron na pong nag-share ng kanilang answer dito sa ating live session. All right. Macready Amir Andres. All right. Thank you po for sharing po, Mr. Andres. All right. So to check whether your answers are correct, all right. I'm now presenting to you the equation. Okay. So ito po ang tamang equation. All right. So we have here in the product side meitnerium, which has an atomic number of 109. So according to the problem, meitnerium is formed by the fusion by the combination of bismuth and iron nuclides. So we write down bismuth and iron and check the atomic number of bismuth and iron in the periodic table. So the atomic number of bismuth is 83 and the atomic number of iron is 26. Right. So we add 83 and 26. So that would equal the atomic number of meitnerium, which is equal to 109. All right. And then let's check on the atomic masses in both the reactants and the product. So Methnium has a mass of 265. And if we look at the periodic table, the mass of bismuth is equals to 209, which and then the mass of iron, which is equals to 56. So kapag inadd po natin ang masses ng bismuth and iron, so that will equal the mass of meitnerium, which is equals to 265. So from there, we can see that the equation is balanced, therefore correct. All right. So therefore, okay, let us take a look at the answers of our live viewers. All right. All right. So, yep. Yes. Okay. Is correct. So, some of our ating mga live viewers po ay are sharing their answers in the comment section, and yes, thank you po. Thank you for the wonderful job of participating po and participating in the and answering the questions in our live session. All right. So ngayon po, let us move on to our quiz segment na pinangalanan po naming Gets Mo? Sagot Mo. Alright. So sa segment na ito ay may sasagutan po tayong 5 katanungan na of course taken from what we had shared to you earlier. We are inviting po our live viewers to have fun and sumali po kayo sa ating Gets Mo? Sagot Mo segment. Just comment po your answers in the comment section. All right, so let's get started na po.
Yeah. Okay, so number 1, which of the following gases are the major components of a star? A, carbon and oxygen. B, helium and carbon. C, hydrogen and carbon. And letter D, hydrogen and helium. The correct answer is letter D, hydrogen and helium. Question number 2. How is energy of a star produced? A, by combustion. B, by decomposition. C, by nuclear fission. Letter D, by nuclear fusion. The correct answer is letter D, by nuclear fusion. Number 3, this element was created by Emilio Segre and Carlo Perrier in 1937 through the bombardment of molybdenum by deuterons. Letter A, helium. B, oxygen. C, uranium. Letter D, technetium. The answer is letter D, technetium.
All right. For question number 4, which is the second most abundant element in the universe? A, helium. B, carbon. C, oxygen. D, hydrogen. At ang tamang sagot po ay letter A, helium. Question number 5. When does a star becomes unstable? A, when it runs out of fuel. B, when it contracts and expands. C, when its core becomes heavy with iron. And D, when the outer shell is pulled by the gravity from the center. Ang tamang sagot po natin for question number 5 is A, when it runs out of fuel.
And So, before we end this session, ito pong ating paksa na tinalakay ngayong hapon ay nakabase sa contents ng Physical Science ADM Modules 1 and 2 ng Region 4A Calabarzon. Salamat po sa inyong pagsama sa amin sa nakaraang 40 minutes na umaatikabong live session tungkol sa life stages ng mga bituin at kung paano na-synthesize ang mga elements sa core ng mga stars.
Alright, let me once again share a quote from Carl Sagan. So, may this quote inspires us that every human life is precious. Every one of us in the cosmic perspective, precious. If a human disagrees with you, let him live. In 100 billion galaxies, you will not find another.
Ayan, so we are inviting everyone to send us their feedback because it matters to us very much. If you are using a device with a QR code scanner, you may scan the code na makikita nyo po sa inyong mga screen. Or you may screenshot the screen for you to scan it later. You may also type in your web browser the link displayed in the bottom of the screen. tinyurl.com #ETUlay feedback form. Again, that is tinyurl.com/ETUlay feedback form.
You may also send your words of appreciation po using the link given. You can also give recommendation if you want someone to be our guest in the live stream next session. So we would welcome it. You may also email your comments and suggestions to the email that you can read in your screens, edtech@deped.gov.ph.
Inaanyayahan din po namin kayo, aming mga minamahal na mga live viewers, na sabayan rin po natin ang ating mga tutor sa General Biology 2 na sina Tutor Easter ng SDO Caloocan at Tutor Tina ng SDO Pasig. After this session po, from 4:40 to 5:20.
You may also watch the live session in Empowerment and Technologies kasama ang ating mga tutor na sina Tutor Jane of SDO Puerto Princesa City at ni Tutor Janelle ng SDO Ilocos Sur. Right after this session po from 4:40 to 5:20. And that's it for week number 1. Once again, isang maligayang araw ng mga puso. Kita-kita po tayo sa Lunes sa parehong oras from 4 to 4:40 in the afternoon. This is your tutor, Tutor Lester from SDO Ormoc City.
And yours truly, Tutor Ronel from SDO Pasig City.
Goodbye and God bless. Kita-kita po.
Ang husay naman! Natapos mo ang iyong tutorial session kasama ang iyong mahusay na ETUlay tutor. May bago ka bang natutuhan? I-share na yan gamit ang #ETUlayLevelUp. Huwag aalis ha dahil may susunod pang programa na pwede mo ring panoorin at salihan dahil naghihintay na ang iyong mga tutors. Happy learning dito sa ETUlay!